Hoy hoy, welcome back to the labs. I'm going to be doing another little take and seeing how far I can get to this. My goal for this video is to do a quick little video poker setup. So similar to one of those little handheld things, taking all of our poker logic we've been building and trying to make something that we can play a quick game with. In a little bit of my reading in the past hour, I've kind of noticed Python 3 accepts Unicode directly, so there's something else I can do to kind of give it a little more of a graphic feel, even though I'm still going to be using the interpreter for this first version of the game. Mind you, it is still, rough prototype, proving out anything. But yeah, let's make a little interpreter video poker. So right now, that's just a function. So one thing I want to point out, like just a function versus a method. Method is on a class, requires self as the first variable being passed to it. There are some things you just have to remember with those. With a function that's not part of a class, you don't have to inherit self from the beginning. So that's one thing I just want to point out since we haven't been doing as much independent functions. But from here, I'm going to just start pulling stuff. We know we're going to need a discard. We're going to need the deck, which is going to be standard deck. Discard's just going to be an empty list for right now. Initialize a player. And now we need to figure out kind of, scoring, handling out, handing out cards, things like that. First thing we're going to need to do is think of these as each hand. So we need to figure out what the loop is going to be for the hand. We know we need to shuffle. Oop. We're going to need to deal out the cards. There's going to need to be a chance to hold or pass on the cards. We need to be able to, well, after holding and passing, we need to be able to score. Oops. Fun part with autocomplete, right? So those are all things we're going to have to do in an individual round. We also need to figure out what the cost per hand is. Actually, what do they start out with a new game? So initial amount, cost per hand, and then the actual hand itself. So for this, just to make this example easier, what I'm going to do is just take random and expect the deck to be shuffled differently each time and just discard the deck entirely at the end of each hand. Not the most efficient for some uses. Other uses, it could be a little better for security, things like that. So I'm just going to be keeping that as my initial frame of reference for this. So our initial amount, let's give them 100. So let's say and fair warning, this might end up being turned into a class, but for right now, this totally works. Our cost per hand, we'll give that, I think 5 is a good number. So let's just kind of go with hand. That sounds like a pretty standard one. So those things are going to need to be outside of the hand loop. So let's make another comment so we can keep track of that hand loop. Create a discard. And really, I'm just creating a discard for if you're wanting to sandy check, do stuff like that. I'm not really going to be doing that much. We're going to create a deck and then shuffle it. Oops. Well, probably should have put that over it, but whatever. And then now we need to actually create, the player, all that. But the player really needs to be up here. So we don't really need him until we get into the game. But he's totally something we need to initialize at the beginning. So let's just give him a home up here. So we have our deck. So we have that part. So now we need to deal 5 cards. So let's go up to our player and let's see if there's a better way we can, append to his cards. So just has his card count. He has his list of cards. Let's give him, or him. I'm personifying my class. You can imagine it however you want. I usually give them various names and things in my head, though that has come into some very funny errors when you actually name your variables that way. My favorite being, can't delete Charlie. Charlie has children. Or I think it was a Python process. So I think it even used the word kill. It was just like, oh, yep, yeah, that's probably when you don't want to use a name. So let's just do an add for right now and just say, from add, you get self and a card. We take that card and self.cards.append your card. Doesn't save much typing, but kind of makes it a little nicer to see. If we really want to make this clear, add card. So down here, when we're doing our player, in our hand loop, we have to, shuffle the deck and then deal out 5 cards. So from here, we're going to take their cards and player.add card. And even though the function took 2 variables, the first one is always implicit. So similar to like shuffle and other things, we don't need to put it in there. But the second one you have to explicitly call out. So for card, we will take deck.deal and give that directly to the player that way. We'll have to do that 5 times. So I actually wonder if I could do that times 5 right there. That is something you can sometimes do in Python. So we will totally try that. So we have that. And from here, let's just test this at this point. So at the very end here, something that will be throwaway, print cards. And I probably need to, self.cards. That is something, or not self, player. That's right, I'm not in the class. Player.cards. And do this in a quick for loop. Card for cards. Oh, and if you're doing it inside one of these, it's a fancy for loop called a list comprehension, in case you're curious and looking them up. In player.cards. Since these are always going to be viewable. Oh, actually, let's see. Card for This might I actually have to do in a for loop because I'm going to be doing something a little different. But in list comprehensions, it's great for just a quick loop when you need it, specifically to like create a list is the best way to word that. And it's always fun to try thinking about these things while I'm trying to work on something. Because with a list comprehension, it's like if you're taking a big chunk of data and you're saying, I want this specific piece of all of those things. It's a really easy shorthand to say, get me the card suit for every card in this deck. And that's really what the shorthand is saying. So instead of saying, for a card in this deck, give me this. So that's the way to think about it. The syntax looks a little weird at first, but easy to get used to. And here we're going to do card dot Is it showing? If I can't remember my variables, okay. That's a reason to update them, though the fact that I guessed it right the first time is actually not that bad. Equals true. So basically we're going to set all the cards to visible, and then we're going to print the cards. So here we'll be able to run, see if that works. I'm just going to copy and paste this because I'm feeling lazy. And there we go. So we ran into our first thing, line 118. So okay, so we couldn't run it that way. I was totally hoping. Because, yeah, just be nifty. But, yeah, for I in range 5 doesn't really matter because we're not using that iterable for anything. We can just call it that way, and that should work. So run that up again. So now we have our deck shuffled, and we have our 5 cards. So we are at stage 1 of a poker game. So let's dig into this a little further. But before I get any further, I want to kind of clean up this first pass of things. I really want to make it easier to work with and easier to just see what the cards are. So right now when I'm looking at this and I'm printing out cards, I'm still getting kind of just this general list of these are the cards, these are these things. So let's do like a hand or a hand view. And one of the things is we can totally do that in the player. So I want to add something. This is totally me just wanting to do something kind of fun and fancy. I'm going to add to the hearts, spades, diamonds, clubs, and actually add some of the Unicode characters. And this is something I just want to test, make sure it works. But it's something that in my testing I've really been liking. Python 2.7 you wouldn't have been able to do this, so that's something to keep in mind. But in here, whoop, that's not the one I'm looking for. So we can do things like spades, hearts, diamonds, and clubs. There we go. So now we have the different suits, but now this is a dictionary, so we're going to have to update what some of these things are. And also, I need to figure out, as you see, like from here, card, I'm creating that card, but I also need something where I can pass that information in. So right here, for suit and suits, right now it'll do the exact same thing it was before. So the cool thing with a for loop and a lot of the things in Python is with its duck typing methodology, it's going to try to process something, and if it can process it, it's going to work. So the same way that we were going through a list would be the same way we would go through a dictionary. The only difference is the default value you get back in that iteration in a dictionary is just the key. But that's what we have right here. So for name and values, we have the name number. For suit and suits, we're getting the name and a symbol. So that shows that in cards, we'll have to be able to add a symbol. So we'll add some logic here. We'll go up to our cards, suit, and we'll give it a symbol. Same thing down here, self dot symbol equals symbol. You know, some of these classes are really easy to build, which makes them really nice. But one of the things is when you first get into programming, having to build this feels intimidating. And I really want to kind of show it in a way where, whoop, I don't need to run that. Let me select somewhere else. There it goes. Really try to show that you can add those things and kind of build them when you need them as well. You don't have to do the memory game of thinking of all the things you need to build or put into something when you first start. Kind of like with art, programming is based off of iteration, and variation is very important as well. I mean, if you're doing the exact same thing repeatedly, I mean, prone to repeat the exact same problems, but it's something that kind of allows you to build off of it. And for something like this, we're needing to get a little fancier with how we're creating these cards. So our names and our suits are going to be right. But then we're going to have to, where is that one going? Expand that a little bit so we have more working room. Though I try to keep my code width narrower, I'm trying to use very clear variables for kind of open source code. So, bit of a give and take with that at the moment. So right here we have our name, value, suit. Let's create our symbol quickly. So, our symbol will end up being our suit. So we take suits and stick suit back into it as the key, which will give us that symbol. From here, we need to figure out what's the best thing to put with that suit in this visual symbol. So let's look at this symbol. I'll give that icon name. Symbol icon. I know I and L right next to each other. Always fun for programmers. So we have that, have our cards. So we need to know what that value is. So for our value right here, we can do if value is less than, I don't know, which one? Jack, it's 11. Oop, and I totally did greater than, so I totally would have messed that up. If it was less than 11, we want to take that value, cast it into a string, and add that symbol icon to it. Else, we want to do something a little different. And here, I think the classic thing to do is just take the first letter of each of the face cards for right now. So, same thing, symbol will equal, and we know we're going to end with that symbol icon. So now we need to figure out what our best way to manipulate that string is. Here, I'm just going to take the name, and literally just slice off that first letter. So make that pretty straightforward. We have our suit, and then right there we'll add our symbol. And in our repr, I'm going to change this a little bit, and it's just going to do a self.symbol. So return. Cool. So now, I don't know why I keep habitually hitting, well, I know exactly why. Keep habitually hitting Control S, and that's totally not how this interface works. Let's come back down here, grab our function name, interpreter video poker. Still not going to be very exciting, because I can only get one hand. But, bam, now we actually have something that's starting to look a bit more like a poker game. Kind of exciting. So now we need to figure out how we want to play that next round. So we have all the way up to dealing cards. Now we need to actually have an input. And this is where we're going to need to have some while loop or some logic to hold it back and make sure they actually give a valid input. If it's like, what cards do you want to hold? And it picked up somebody saying like, oh yeah, my wife is kicking up a drink or grabbing the kids or whatever else, it's not going to be useful. Same thing as like, voice commands have to look for specific things. We need to write what we want it to look for specifically. And since this is going to be a really, really simple interpreter game, I'm just going to show you how to parse a string and get ints out of it. So let's jump into here. And for this hold versus pass, let's start a variable, as I said, something that we're going to be able to check to see if it's been run correctly. So hold verification, hold verify. held. Okay, I'll just start that with false. And for here, we're going to need something that we can test. So while not held, we're going to need input. And what input does is it kind of stops everything and requires you to type in something. So I'm going to use that, and it's going to pull back, input string. And I'll just give it something like that first until I can verify, what is actually in it. We need to be able to take that string, and this is going to be just comma separated, comma delineated. So we're just going to take our input string dot split, and we'll give it a comma to split that on. So that will do that. Now for each one of these, let's do. Oh. I'll just call it an imp. Meh. Programming's great because you get to make up words all the time. Int for So I'm going to add one more thing. It's going to be just a dot strip. If you don't give it anything, what it will do is try to strip white space and things like that. So for right now, we want to split on those commas and be able to make sure we can split that. So for here, I'll give a quick example of that. If I'm giving that and I want 0, 1, 2, 3, 4. So that's a great example right there. Because if I'm doing a test here, we'll run through this. Test.split on commas. You'll kind of see those spaces are already there, but comma character is already erased. So if we do that same thing here, we're just going to take that and strip off that white space at the end, and then have our input list. Now for each one of these, and actually, I'm going to try making this a little fancier. So I'll put this in a try, make it very Pythonic. And when I'm doing this, I'm going to try to take that and cast it into an int. So right there, it's just going to, give you your error, to some extent, because I can do an except. So it'll try to do that. If that input list doesn't work, try will print error. Try to think of the most friendly way to say this, but yeah, input error. I'm trying to think the best way to do this. I might be able to get away with just printing out 2 lists doing that. But yeah, I'll just do that 1, 2, 3, 4, 5. Same thing, we're going to do that, and then we're going to try testing this. So we have our input list. Now I want to try doing a little more on this. So I need to be able to check for input in, input list. The number has to be less than 6. So imp Wonder if I can just use that as arrays or if that will actually error out, error out. We'll totally see. So we have that. Let's just run this and test quickly. So we have our video poker. Oh, haha. It didn't print our cards yet. So let's just do our 1, 3, 4. Okay, so that totally errored anyway. Let's go through here and print our cards first. Now I'm just going to add some user-friendly text here. Okay, so, boop. Stop that. So now we'll try to get this a little better. Let's add this print and put it in the try. Run that. Yeah, kind of helps to be able to see my cards, I guess. Print player cards. Have to do that right before that. Okay, that'll help. So now we can run that. Cool. Which cards do we want to hold? So 1, 2, 3. Error. Which cards do you want to hold? Why is this erroring? So we'll stop that. We will try to print our input list right there. Run that. Cards you want to hold. 1, 2, 3. Didn't that print? Oh. Helps to actually write print sometimes. Not all the time, just sometimes. One, two, three. So it's not erroring there. I think that's getting an error just because of its format. So I will get rid of that raise. Oh. You know how that might work better? I think I'm supposed to use continue there. Cool. Let's say 1, 2, 3. Bam. And now it just kind of goes back to the beginning. So now we need to figure out how to finish this loop. So from here we know we're actually getting our input list. Let's see, print that. If that continue, else, yeah, if something's greater than 6, continue. Let's add some other logic here to make sure it's not going to break or do something dumb. If it's less than 1, continue. So we essentially have a cap. Or oh, is greater than 6. That might have helped a little bit. That might have been why we were getting that error anyway. Cool. So we can do 1, 2, 3. Cool. And from here, now we can break this up a little bit more. So which ones do you want to hold? If we get this, now we can deal out different cards. And for int, for input in input list, now that we have that cleaned up a little bit, we want to take the player's cards, slice it by that input, -1, because you want 1, programming wants 0. So from there it'll be pretty easy to, kind of get this. That's going to be our index. Well, then we just need another card. So we call our deck.deal. Boom, we have replaced those cards. But now we need to print again. And that's where we're going to do our printing and our scoring. So we have that. Print our cards again. And I actually might put that in the loop itself. So, which cards do you want to hold? I have that twice, so I'll get rid of that one. And we have print player cards down here. We've just dealt a new hand, so we'll print those cards again. And with this accept, let's move this up a little bit to there. Oop. I guess we're not using held at the moment. So I will actually just do our while loop a little separately, but we'll be able to still kind of add some ways to break out of this logic at times. So let's look at this right now. Because that allows us to get that. We get a new set of cards. It allows us to just hit enter if you want to keep your cards. So which cards do you want to hold? Let's just add that as another line. Just hit return to hold all. I'll just add a little asterisk to there, make it clear that's a little note. I'll stop that for a second. So now I'll stop, take a look at this, make sure that's right, replay that. So those are our first ones. We want to try getting rid of 1, 2, 4, 4, and 5. So from here, hit enter. We can get rid of that extra print of the list. So that's already verified. And now we can see we didn't update anything at all. So let's take a look at this quickly. Player cards. That card equals deck.deal. Ha, yeah, that would do a problem. There it goes, let's stop and restart that. I just had it nested wrong, so that was totally in my try loop. So 1, 3, and 5 are the ones. Actually, let's just get rid of 1 and 3 at the moment. So let's take a look at what just happened here. Oop. That needs to be in this section. So these prints don't really need to be in the try. Just doing some quick code cleanup. Okay, so now we're getting our input list. Let's see. Oh. This part I totally need to try, huh? So now we're going through here. Let me check and see what I am doing. So walking through our logic while held. I guess while not end. Let's just make end explicit. So these are the things that will be constant until the end. So these are things that will just constantly loop. So now while we're thinking of this as a game loop, this makes this a little easier. So, because things like the player card, stuff like that, that's something we need to have nested within another loop. So from here, or actually, let's see. I'm going to break that logic out a little later, so we'll just jump back to that in a little bit. So we have that, we're getting this, and that lets us deal those cards. So I will actually strip out a couple of these. Let's see. So we need to make sure they're all numbers. They all could be cast into ints. So that we're checking right there. I think we can also do an if int, just to check to make sure that it's not empty first, because if it's just an empty space, that should catch that. So we have that, we have this, and we have this. So these are things that need to replay each hand. Because I'm looking at this, these are our top level things. These things are things that need to be created once, basically. Here, though, we're dealing out, so that's something we need to put in a loop. So that we create, we shuffle the standard deck. So I'm actually going to move this while not end quite a bit higher. Because then for each hand, we're going to create a discard, create a standard deck, shuffle. I kind of want to add some more logic to do a cut and stuff in there to make the random a little more random, but we can get to that a little later. We add cards to the hand. We have this end equals false right there again, so let's double check. Make sure we have end, while not end. So we have to take that part, make sure that is outside the loop, or else we'll never be able to really fix that. Clean up my comments no longer make sense. So we're dealing out the cards. Make them visible. And then we're going to print the cards. That one's pretty self-explanatory. Then we're going to do another while loop. So I think, yeah, this is where I kind of want to try doing something a little fancier so we can keep doing a while loop inside of a game loop. So here, while not, what are these going to be? Valid input. valid input will be none to begin with. Make that very explicitly clear. This will give us an ability to do our input, print what cards you want to hold, just return to hold all. Try doing this. This list comprehension should do nothing if nothing is there. For this, same thing. For this, same thing. So that should pass through. The other case is if we're giving it numbers. So here we'll try to give it that. And at the very end of all of this, player cards, deal, we should be able to, if it gets down to this point, valid input equals true. Here, instead of none, I'll make it false, make it a little clearer what I'm using it for, just because didn't realize it at first. But now we'll be able to keep having a loop for valid input before going back to the next hand. So we have that. Stop this. One of the things I want to do in each one of these main loops is do a quick print. You have so many points. This is how you do formatting. Dot format. Initial amount. I'll just say points. Have I used initial amount anywhere else yet? Nope. You have now been deemed points. So we have that. I'm just going to do an empty print to just get a next line. There it goes. Prints cards. Which cards do you want to hold? So once it gives valid input, we break through that loop, which should be good. And then we need to score. So I think that actually might be, let me sanity test this. Yeah, so that should be the last part we need before being able to score. So I'll print these cards first, and then we should be able to test this part quickly. Run. Cool. And just return is to hold all. Totally want to swap that to the other default, but meh. 3, 4, 5. I want to get all of them we placed. So let's look at what we just did. Okay, so not valid input, we print playing cards there, print playing cards there. Why did our deck not get reused? So valid input is there. Okay. So at the very end of all this, let's clear the player hand. Player.cards equals nothing. We're just going to nuke them. I don't even think we're going to need the discard pile for this, so I'm just going to nuke that up there. Stop. Run. Cool. So now I want to try 1 and 2. Huh. Okay, so that is definitely a change. Deck shuffled because it just played through. Okay, So now we're getting, as I said, something that's looking a little more like a poker game. Gonna try finishing up a couple things and add the last couple rules, and hopefully have a working little handheld style video poker game. Nothing very complex, but something we can start building off of in later classes. So let me take a look and review my code quickly. Okay, so now that we're printing these cards again, so we had 100 points, bam. So on all of these new cards we're doing, we need to do deck.deal, which returns the card, and I'm just going to set that player cards right after this, dot showing equals true, because we just need it showing all the time, really. So that should fix that quickly. Get this in here. 1, 2, and 5. Cool. So our 1, 2, and 5. I actually, well, that wasn't really a good hand, but it's like, wow, I got a lot of face cards. So yeah, I still have 100 points. Now we need to score from there, because now we're actually getting something kind of real there. So for here, in our scoring, I'm just going to go from what the video poker kind of handbook thing is. But one of the things I realized I kind of need to do is in my straight thing here. So I don't think I'm actually using that anywhere in the code, even though I was testing it a little more directly myself. So yeah, pretty good sanity test on that one. But one of the things I kind of want to do is, instead of just returning true or false, I need it to return the highest value. So for something like this, let's say, if it is an ace low straight, 5 is really the highest value. And in this one, that one's false, that one's false. We want the highest value. So value 4. So now straight will actually return a value, which is pretty cool. Because in here, when we're doing our scoring, we need to see, like, essentially, royal flush will be the top one. From there, where did my video poker one go? There it is. Straight flush will be the next one. And so on. Let's see. I know all of these, I swear. Four of a kind. And it's kind of funny how well, like, you can, like, know something like this kind of without thinking about it, and then when you try to think about it, it's like, wait, what one comes first? Like, flush and a straight always do that for me, where when I'm playing, I totally know the odds and stuff, so it's like, oh yeah, I totally see which one's rarer, and then when I'm trying to write something like this, totally have to write them in order, or else I'll totally forget. Straight. Three of kind. Two pair, and jacks are better. Okay. So from here, we're going to need to be able to see, is this a royal flush? So one thing that we'll be able to do is, score equals, poker score. Yep. My autocomplete failed me. And we give that player cards. So here we can ask score dot straight so if score dot straight and score dot flush And I'll take a look at this quickly, just double check, make sure that'll work. I'll just grab these as top level things so I don't have to run that function every single time. If scored out straight. And these are things just because these aren't changing. It saves a bit of memory. Not really going to save much. But now we can say if straight and flush and straight equals 14, which is the value of value of ace, and I'll find my thing and sanity check that, ace, we have a royal flush. So at that point, you know, print royal flush, or need parentheses first. Okay, so now we have our royal flush. Similarly, we're going to just keep going down these. This will be an elif, and this will just be straight and flush. Don't know why I'm adding extra colons there. Then it's a straight flush. Yep. Elif, now we need to do a 4 of a kind, and there's a couple different ways we can do that, but one of the ones that I think will be the easiest is just count the different cards. So if we have, you know, all the different cards and we only have 2 different types, we know it's going to be, you know, one or the other. It's going to be either a full house or a 4 of a kind. So that gives us a little bit of information right there. So from there we can kind of figure out a little more. Let's take a look at this quickly. So the next one, double checking, we totally want to just check 4 of a kind. So in here in our poker score, let's add another one here. 4 of, I'll just say 4 kind for now. La-di-da. Okay. And I think this should totally work, so we'll try it. But it'll check and see. This should count, so we can test this in a list quickly here. If we have, you know, like 1, 2, 1, 3, 4, 5, 5, 5, we should be able to x equals x dot count 1. We should be able to see how many 1s there are. Same thing, we should be able to say, you know, how many 5s are there. So really what I'm doing here is I'm just saying, you know, give me all the values, and for each one just count them and see what they're going to return. So in this case, if count equals 4, return true. So that makes this a pretty easy 4 of a kind check. So same thing, we can come down here, elif 4 kind. Oh. Let's see, score dot. Print. Kind of seeing the pattern here. Oops. 4 of a kind. And just copy and paste this because I'm starting to feel lazy. As saying, not the most friendly interface, but let's see, how much is 4 of a kind? That's 125. Cool. So the next one we need to be able to figure out is a full house. So similarly, let's come up here, def full house. And we're going to take the same values. But here I'm going to just do a quick check. So I'm going to do a 3 equals false. And, well, I should probably do them in order for it to make sense to people, but meh. 2 is also going to be false. So in here, same thing. If value count equals, so we'll put this in here. But we're not looking for 4 anymore. We're looking for 3. And if there's a 3 there, we turn 3 equals true. And if there's a 2 there, we do the same thing for 2. I did the same thing, totally did them backwards order, so I'll fix it this way. So now we can start saying kind of how many of things we kind of have in here. This will tell us if we have a 2, if we have a 3. Go through our card values quickly. If 2 and 3, return true. Yep. Kind of helps to spell that correctly. Return true, else return false. So that's something that we can quickly check if we have a full house. Same thing. I'll just copy and paste this entire chunk. Do. Full house is 40. What is plus 20? Similarly, let's add these so we're actually incrementing these points and not just like telling them like, hey, you won something, because I think that would feel even worse here. So there, 5, 40, 25, 20, and then now we're getting to the last few of these that I need to get a little more logic in there, but the same thing is, let's check for that 3 of a kind. And actually, for the 4 of a kind, I'm actually going to change this a little bit, but let's try this. We'll add both functions. Highest count. So this will just count and see what that highest count level is. So similarly, we're going to take these values here. And similarly, for value and values, count value. And then this logic I want to change a little bit. Instead of if value count equals something, I want to get the one that has the highest. So let's just put, highest count, or count for right now. Yep. Equals 0. For each one of these, if that is larger than count, count equals okay, we'll just do it that way. So now it's going to check to see what that highest count value is. And we can use that a little separately here. So we can take that count, return count. Now we have something that's going to give us that highest count. So up here, similarly to how we took the scoring logic, let me see, and did straight and flush. Now we can also do, whoop, cool. So now this will give us the highest count. So for one in here, so for 4 of a kind, we could do score 4 of a kind, or we could do score high count is equal to 4. So I don't really need to do that right now on that one, but that would be one that we could use for both the 4 of a kind and the wow, I totally saw something that blanked my mind. And the 3 of a kind really easily. So I'll put it in here with the 3 of a kind. So let's grab one of these. Highest count is equal to 3. 3 of a kind. Oop. And 3 of a kind is worth 15 points. Cool, update that one. And there was one of these that I totally saw. Okay, so the full house. We're going to need to be able to check both a pair and a 3 of a kind. So let's take a look at these and see what the easiest way for us to do this one is. High card, highest count. Oh, we already did a full house, that's right. Derp. So, full house. Cool, flush, straight, highest count. So now I need to do pairs. So I can totally check. I might just write these as 2 separate functions for the moment to just get this done quickly. We could totally update it a little bit more later. But the next one is just looking for 2 pairs. So is there anything I have that I can utilize at the moment? Not really, but I'll just jump in with one of these things here. So I need to figure out def 2 pair. Same thing, give it self. And there are ways, as you see, we are kind of recalculating, repulling some of this data sometimes. It's not going to be too much of an issue in this use case, but there are ways that we can optimize this. So that has been kind of asked, and yeah, we can totally fix that stuff up a little later. So now with the 2 pair, take the same thing I was doing here. You know what I'll be able to do here? We can do, let's change this to pairs. Whoop, pairs. And then we can see for each one of these, if the value count equals 2, going to need to bump that one. So from here, we'll just call them pairs. I don't know if that's going to work. That might give me an error since they're both the same name, but let's see if it allows me to do this with scope here. Okay, so we have that, we have pairs, we'd already be checking 4 of a kind, we'd already be checking 3 of a kind, trying to think of anything else this would trip up on, but I think this is good here. So for all these pairs, if we get a count of 2, we need to add it to pairs, but we need to make sure we don't have the same count of 2. So, yes, I see a way to do this. So if there's a count of 2, and value not in pairs. So this way we're going to check and see, you know, hey, does this value show up at least twice? And is it not already in pairs? Because if you have that same pair already, it's 4 of a kind or 3 of a kind, and those are things that we're already checking. So if it's that, pairs dot append value. So that way we should get this and then be able to return pairs and see how many there are. So similarly, as we're up here pulling this, we can just say pairs equal score dot pairs. And then here, 2 pairs, if len pairs equals 2. That makes that pretty straightforward. I'll put that in elif so it's in the same chain, and let's add more to this. Print 2 pairs. 2 pairs is 10. Actually, give them 10 points. And if jack or better, elif pairs and pairs 0, because there will only be 1 pair if it gets down to this point, is greater than, and what's our score? Oh, greater than 10. Cool. And then we can do print, and I'll just call this jacks. Jacks are better. Cool. Same thing. Let's give this 5 points. We've almost got a working poker game here. Okay, so that should score. One thing we have to do for each hand. So we have to decrement our points. So when we first start, you start with your number of points. That's out in this while loop. You have X number of points. So when we deal these cards, we have to take 5 away. So let's just do player.points minus equals 5. So that way we're taking away 5 points at the very beginning of each round. And down here we're kind of getting our points back for that. I do not know what this last player card... Oh yeah, that's clearing the cards at the end. And then that should go to a while loop. Let's add some prints down here to give it some space between a couple rounds. Let's give this a shot. So now we should be able to run this. Yep. And start our interpreter. Player has no attribute points. So we're in line 162. Let's jump to that and take a look at what I messed up here. So player.points. Player object has no attribute points. Oh, that's right. Points is a game level thing. So that's just points minus equals 5. Run that again. We have 100 points. Deck is shuffled. So now, let's take a look at these and say I want to get rid of, or hold. These are the ones I'm holding, right? I think I did the cards I'm trying to get rid of, right? Yeah. So let's change this wording quickly. Let's also put these prints above that input, because that'll make way more sense. And let's correct what they're printing. Yeah, and then just hit return to hold all. That makes a bit more sense. So we have that. That should be saving. Stop, and we'll retry this here. So I want to discard all of them. So 1, 2, 3, 4, 5. And I get an error. Let's see which one this is here. Value is not defined in line 87. Oh, yep. Values, 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 values. Okay, and I'm also going to reorder these because this is a little weird. So we have that one. We can take this one. We'll grab all the way up to the space. Snipe that. And that, so same thing. I'm just cleaning this up just because it'll look a lot nicer and make a little more sense. So we have, you know, ace, 2, 3. Oops. And-anded. So, okay. And that. So we have that. We run that again. Which ones do I want to discard? 1, 2, and 4. 1, 2, and 4. Okay. So, forgot my pluralization here. Okay. Think I have that time. So I want to get rid of card 3. Well, this one's a different value not defined, but copy and pasting has its issues. Let's see. Values, 138, count that in values. And this is a good way to sanity test some of the stuff. 1, 3, 4, because I had a horrible hand anyway. Highest count is not defined. So let's see. Line 245. Didn't I already put that in there somewhere? Oh. Highest count. Okay. Another sanity test here. The joys of debugging. 1 and 5. Cool. I didn't get much better cards. I have 195 points. And we reset. So let's keep trying this here. Let's see if I can break it. So I have 2 queens. I want to get rid of my 5. Okay, that didn't help me. 1, 4, 5. I haven't won anything yet, have I? Let's see. 1, 3, 5. Boom! Got a new error. Sweet, though I did, get it to test all the way down to that point. It says 2 pairs, 2 5s, 2 jacks. It totally got that right. So yeah, now we need to go down here, and apparently I did that player.points thing. That's probably exactly where I got that from. So we'll fix those things. Cool. 3 and 5. Not saying I'm actually good at this, but yeah, jacks are better. Sweet. +5. I have 100 points again. So let's try this with 1 and 5. Cool. 4 and 5. So I don't need to sit here and play the entire thing, but you kind of get the idea of what we're trying to build. And 1, 2, 3, 4. And from here, we're able to kind of build something where you can start seeing kind of a visual side to it. So yeah, it's not really clearing as much, above it. But if you're imagining this refreshing versus, just scrolling up with each time, this is now a fully functional video poker equivalent. But there are a few things we would need to fix up before trying to release this or do anything else with it. But from this point, yeah, this is totally functional in all versions of Python 3 as long as I'm aware, or as far as I'm aware. And we have the suits, the Unicode stuff in there. We have the classes and other things. So yeah, I'm totally going to do a wrap-up video and all that. But yeah, trying to get an entire poker game live without notes in 3 hours. I ended up being about 15 minutes over that, but hey, definitely a fun project. So yeah, thanks for joining with me. As before, I'm going to be taking all of the Python code. I might add a few more comments and stuff just to clean it up a little bit, and I'll be putting it on the Google Drive page for Change Machine Labs. And yeah, if people have any other questions, comments, or anything else, it'd be great to hear their input. I know this one was a little less planned and rushed than some of my other videos, but part of it was to get some of the content out there, because now I'm going to go through and start doing videos like the introduction to Python, kind of explaining some of the programming theories, and kind of merge the two things together. So, hope you learned something, and if not, hey, you get to play around with a video poker game and anything that has Python 3, which is almost everything these days, especially with web and all that. So, as always, had a great time. Talk to you guys later. Peace.